What's up guys? Welcome back. So today I'm going to go over an exam I made for my year 11 extension class, and to be honest they didn't do too well. So if you're one of those watching, hopefully you can find out where you went wrong, but otherwise I'm just going to go through some of these questions that are on the edge of like the harder advanced but also a little bit of extension stuff. So let's get into it. Alright, here's the first question. The following sector has an arc length of 19 centimeters and an area of 76 centimeters. What is the exact length of our radius? So straight away, length of an arc is this formula here, L is equal to R theta. And I've also got area. So I'm going to need both these formulas, okay? So area of a sector and length of a sector. So first of all, let's just do a substitution with this first equation here, length. So I know the length is 19, and that's equal to R theta. And I don't really have anything else I can substitute in there, so let me just leave that here for now. Okay, and then the area, right? The area is 76 centimeters squared, and that's half R squared theta. Okay, so that is my second equation here. Now, hopefully you can see I'm going to form some sort of simultaneous equation, and I'm going to manipulate this and substitute it into this. So, coming over here, 19 is equal to R theta. So let's say theta is equal to 19 over R. Okay, and now I can substitute that into my equation here. So 76 is equal to half R squared times 19 over R. Cancel the R's out. So you can have 76 is equal to 19 on 2R. And I'm basically going to divide 76 by 19 and times it by 2, okay, because I need to get rid of that figure there. So R will be this. R is 8, okay? Done. Okay, here's the next question. Solve cos 2x is equal to minus root 3 on 2 in the domain of 0 to 2 pi. Okay, now these trig equations are usually pretty straightforward unless that is not just x by itself. But we can make it something like that. So I can say let u equal to 2x. So cos u is equal to minus root 3 on 2. Okay, and then I can kind of solve it like I normally would. So first of all, I need my all stations to central, and I know it's going to be in these two quadrants because cos is negative here. And then second of all, where do I get root 3 on 2? Well, from my exact value triangle, and I think I need this angle there, which is going to be 30 degrees or pi on 6 to give me adjacent over hypotenuse. So now I can put it in my diagram here. So I'm going to have pi on 6 here, pi on 6 here. Okay, so going around the circle is 0 to pi and then pi to 2 pi. So I've got 0 to pi to 2 pi. But because we're using with a denominator of 6, I'm just going to make that 6 pi on 6. I'm going to make this 12 pi on 6. Okay, that way I can quickly tell, all right, what's this angle going to be? Well, it's going to be 6 pi on 6 minus pi on 6. So u is equal to 5 pi on 6, and then 6 pi on 6 plus pi on 6, so 7 pi on 6. Okay, now, because there's a 2x there, it tells us we've got to go twice around the circle. So all I need to do is add on another 2 pi to both of these, and I will have my solution. So 5 pi on 6 plus 12 pi on 6, that's going to be 17 pi on 6. 7 pi on 6 plus 12 pi on 6, that's 19 pi on 6. Okay, almost there. We're not solving for u, we're solving for 2x. So let's replace that. All that. Down here. And now divide everything by 2. So 5 pi on 12, 7 pi on 12, 17 pi on 12, and 19 pi on 12. Done. All right, question C. Show that sine 75 degrees is equal to all that jazz on the right. Well, what you need to do here, you need to split that 70 up into a 45 and a 30 to make up that number, because these are sum and differences of these trig identities. So sine 30 plus 45 is equal to sine 30 cos 45 plus cos 30 sine 45. It's pretty easy to remember, it just alternates, okay? So sine 30 is up here, so that's going to be opposite over hypotenuse, so 1 on 2 times cos 45, which is 1 on root 2, plus cos 30, which is root 3 on 2, times sine 45, which is 1 on root 2. Okay, so just simplify these in pairs. So that's 1 on 2 root 2 plus root 3 on 2 root 2. Bring it together, so that's 1 plus root 3 on 2 root 2, and you are done. Okay, question D. Write cos 3 theta and cos 4 theta as sum of trigonometric ratios. Now, once again, you don't even need to memorize these because these are on your formula sheet, but these are just like the sum and difference of these trig ratios. And so I'm just going to copy it here. So right there, that is the formula we need. And we're literally just matching up these for A and this for B. All right, so there and there. All right, so here we go. So cos 3 theta, cos 4 theta is going to be 1/2, open bracket, cos 3 theta minus 4 theta, plus cos 3 theta plus 4 theta. Okay, so that's 1/2 cos negative theta plus cos 7 theta. And you're pretty much there. But we need to just simplify this thing here, cos minus theta. So that is just going to be a positive cos theta. Now, if you're not sure why that's true, think back to your unit circle, okay? So your unit circle looks something like this. And if you think back with a radius of 1, this length here, this x value, is always x is equal to cos theta. Okay, that x value is there. So what it's saying is if we go negative, okay, if we go minus theta down this way, minus theta, well, that angle there is still going to give me this positive x coordinate. Okay, so it's still going to remain positive. So it's cos minus theta here is actually the same as theta up here because it's going to be the x axis. Okay. All right, E. Express sine theta and cos theta in terms of basically our t formulas. Okay, so if you don't know this, it's this formula here. So you're going to have 2t, 1 minus t squared, 1 plus t squared. And this is basically what we're going to be using. Okay, so this is theta here. So sine theta is equal to opposite over hypotenuse. Cos theta is equal to 1 minus t squared adjacent over hypotenuse. Okay, now hence show that all of that is equal to t, so let's just do a substitution. 1 plus 2t over 1 plus t squared minus 1 minus t squared over 1 plus t squared, all over 1 plus 2t over 1 plus t squared minus, plus 1 minus t squared over 1 plus t squared. Okay, now it's a bit of a mess, but straight away I can see that all of these ones with denominators are all the same. So what I can do is I can multiply this, this, and this by 1 plus t squared, and that's going to cancel those. And then likewise, I'm going to multiply this, this, and this by 1 plus t squared to cancel all of those. So I'll just do it on the right-hand side. This is what we're going to have, right? Timesing everything by 1 plus t squared, that's times 1, plus 2t, minus 1 minus t squared, so put in the brackets, over 1 plus t squared, plus 2t, plus 1 minus t squared. Okay, so I've just multiplied every single term on top and bottom by 1 plus t squared. Expand and simplify. So 1 plus t squared plus 2t minus 1 plus t squared over 1 plus t squared plus 2t plus 1 minus t squared. Okay, mouthful, but I think we're almost there. So 1 and 1 cancel. You've got t squared plus t squared. That's 2t squared plus 2t over. These t squareds cancel out. And the bottom looks like 2t plus 1. Factorize, so 2t outside of t plus 1 over... Oh, sorry, this should be 2. 2 outside of t plus 1. Cancel, 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 cancel. Done. Okay, this is the last question. So given that 2 cos squared x is equal to 1 plus cos 2x, show that cos squared 2x is equal to 1/2 1 plus cos 4x. Now, To be honest, this one I was just kind of giving away free marks just to build up the question, make it a little bit easier for part 2, because part 2 is a little bit tough. But in any case, all we're doing is we're replacing, well, first of all, we're moving that to the other side. So it's going to be cos squared x is equal to half 1 plus cos 2x. All right. And then all I'm doing is I'm literally replacing this by 2x and then this by 2x. So it's going to be cos squared 2x is equal to 1 half 1 plus cos. Now it's going to be 2x, right? That's going to give me the 4x. So as you can see there, that's going to be 4x. That's done. Okay, hence prove that 8 cos 4x plus 3, 8 cos to the power of 4x is equal to 3 plus 4 cos 2x plus cos 4x. Okay, so what you need to do here is actually need to split the left-hand side up. Now, once again, there's probably many ways to do this, but let's just do it this way. This is how I did it. Okay. All right, now once you've got this broken up, it says hence, right? That means you should probably use what is up here to help you. So I can see that cos squared x is giving me something here. So let me just replace it. So 8 bracket 1 over 2, 1 plus cos 2x times 1 over 2, 1 plus cos 2x. Okay, now let's get rid of this 2. So it's 8 times a half, that's 4, and then 4 times another half, that's 2. So let's put that 2 at the front, and I'll have 1 plus cos 2x here, 1 plus cos 2x here. Okay, now next logical thing would probably be just to expand the inside. Okay, so 1 plus 2 cos 2x plus cos squared 2x. Okay, almost there. Now, once again, hopefully you realize with this is just this bit here. Okay, so I can also replace that. 1 plus 2 cos 2x plus 1 half 1 plus cos 4x. Okay, now I'm getting pretty close. If you compare what I have here to what I need up here, it's getting closer. So let's maybe get rid of the 2 by expanding it inside. So 2 plus 4 cos 2x plus 1 plus cos 4x. Right, because 2 times a half is 1. You just get rid of the brackets. So then finally you've got 3 plus 4 cos 2x plus cos 4x. And you're done. Alright, so that's the end of the video. I hope you enjoyed that. If there's any questions or other videos you'd like to see, hit me in the comments below. Otherwise, thanks for watching and I'll see you in the next one.